Hi, Ronak.
Hi Kalyan, how are you?
I'm doing good, thanks. How about you?
Very well, Kalyan.
Okay, so today the question that we all want to know in Tech in Depth is why and how is PlantOS the world's most user-validated prescriptive AI platform? What's the secret sauce? What does it really mean? And how can somebody understand it?
Sure.
Fact and evidence.
So Kalyan, see, basically, user validation is part of the flywheel that drives infinite uptimes technology, right? Every validation that comes from a user either improves our algorithm's confidence or accuracy, right? So if it's a true positive, the confidence improves. If it's a false positive or a false negative, the accuracy improves because now you know what to do better or what not to do next time, right? And we've built models based on data and based on global knowledge together for all the critical equipment and applications in the heavy industry segment. So we have models for roller presses for cement, for example, very precisely. We have models for VRMs, we have models for classifiers, for ball mills, right? For deep pen conveyors, for example, right? Which have been trained on lots of user feedback. So we give better insights and better prescriptions. And as we give better prescriptions, the user validation improves even further because they like the prescription that they're seeing. It's adding value to them on a day-to-day basis. And that's how the flywheel runs, right? Um,
Mhm.
what you can see on the screen is a diagnostic report
Mhm.
coming for a particular equipment. It's an air fan. You can see the observation. And this is by NITI, by the way. So there's like no human intervention. It's happening on its own, right?
Mhm.
You can see the observation, the diagnostic, unbalanced fault detected, recommendation, very clearly what needs to be done to fix it, action taken, a 1 hour of downtime saved, timestamped by the customers, by the user. And that's a
Mhm.
user validation. And of course, we can go into the detail and actually see how that has impacted and what exact comment was given by that particular customer. Right?
And
Here's another
that
one.
looks very interesting.
Yeah.
If I may ask, I mean, can you please take us? Let's follow the onion model. This is what is the final impact and the result and the user feedback about it. Great, excellent. Now,
Mhm.
if I have to look at it, there is a magic that happens. What the customer states, hey, you know what? I would like you to please help me optimize this particular key equipment in this particular in the previous example, like you said, it's a blower or a fan,
Mhm.
or maybe a ball mill, whatever is the example that you've quoted, vertical roller mill, ball mill, deep pan conveyor, etc. From that stated goal to seeing this and validating this, I'm sure there is a series of steps that happen to which is why this is happening. Yeah, if you can help me uncover one step behind like this, following the onion model in a layman's language,
Mhm.
what exactly happens from an expected goal of, let's say, a customer talking to me and then telling me, hey Kalyan, this is what I want to be taken care, to the end goal of what you just showed, me showing to the customer, look, sir, this is how it is solved, and do you agree with this? And the customer giving feedback, thumbs up, yes, I did that. It's a pinpointed prescription. Perfect. Now, help me uncover these layers, please.
Yeah. So for that, I'll have to go to our diagnostics toolbox. Can you see my diagnostic toolbox?
Hmm.
So what is it? What the model does is, so we've got a lot of
So we
different.
are at step one. So, sorry, Ronak. We are at
Yeah.
step one. I stated a goal that I wanted you to please help me optimize a asset, and after that, help me understand the layers.
Yeah. So basically, we start getting what is two types of information, right? Your time series information, your spectral information. So in the time series information, you can actually see all the various important parameters. Now, these are also a combination of raw parameters and computed parameters, right? So you can see the vibration levels, the temperature, the accelerations. Then we also have some other computed parameters like the RMS, like shockwave. Shockwave is our method of doing, demodulation to amplify high frequency, bearing faults. We have something called priority, which is, our syndication priority, which our AI model kind of gives out, is that this is an important or critical equipment, which there's a change in the spectrum pattern or the signature pattern, which is automatically analyzed. We have this time waveform. The time waveform runs through an image processing technique, which identifies unusual impacting patterns in the bearing of that equipment. And we have all the important information for that model to get the right diagnostic. For example, what is the bearing number? What is the rated RPM, right? Variable RPM. What is the mounting condition? What is the coupling? What type of equipment or asset type it is? This is the model which gets chosen at the back end, right?
Mm-hmm.
Then from a spectral decomposition point of view, of course, you have velocity acceleration. We have something called shockwave. Shockwave really goes into very useful for bearing faults and slow speed equipment diagnostics, right? We have something called Cepstrum. Cepstrum is very useful for slow speed gearboxes. So as I said, we have a model for roller presses or VRMs. We use a lot of analytics around the Cepstrum technology. Then you have the spectrogram. Spectrogram is useful when there's continuously varying RPM. So think of an uncoiler or a recoiler in a steel industry or a winch application where that RPM is constantly changing. It's not continuous at any point of time. And then you kind of want to do order tracking there. And your PSD is your power spectral density, really looking at where the power is really consolidated in some sense, right? So that is the various decompositions that we do in our system. We also have various methodologies to look at changes in pattern. So we look at pattern change in the spectrum shape. We look at pattern change in the time waveform. We look at pattern change in the time series data as well, right? Which is more from a trending and equivalent perspective. We have long-term, short-term, mid-term trends, and certain deviations around those, right? And then also you do the analysis of the bearing fault frequencies along these various things. So whether it's the velocity or the acceleration of the shock wave, we actually look at whether there's any correlation with the bearing fault frequencies to pinpoint that particular fault. Now, all of this is happening in the model, right? We don't have to sit and do it ourselves. All this happens in the model.
Just one basic question here. I understand that you're talking about the deep dive analytics across FFT, spectrum, time waveform, and maybe more parameters and views that you're looking at. But the anomaly detection, it happens at the sensor level or in the cloud? The first time when it comes to actually the detection part, something is wrong, it happens locally or it is in the cloud?
It's in the cloud because the model decides whether it's something that needs to be looked at or not. So everything is done on the cloud.
And how frequently does the model get the feed?
It's on a continuous basis, few seconds.
Okay. Let's say every 6 to 10 seconds or like half a minute.
Can be anything. Can be anything from 2 seconds onwards.
Okay. Because it depends and this is something that you configure depending on the complexity of the asset.
It's auto-configured. So it depends on the RPM. It depends on the type of equipment, right? And the failure modes that you're trying to predict. So if it's a gearbox, you'll start looking at more higher frequency ranges. If it's not a gearbox, right? So you're not looking at GMFs, you're looking at lower frequency ranges of interest. Then the Fmax LOR changes accordingly, and accordingly the time interval in which you get the data changes. So it's all auto-configured. No one has to do anything manually. And once you decide what is the RPM and the application, it's automated.
Okay. The physics part of it is something that you're showing. If I request you to please break down what is the AI part of it. Now that this is here, what are the 3 steps or 4 steps that happen from here till you generate a DRS report, digital reporting system, a prescription, a pinpointed prescription? What are the 3-4 steps that happen precisely from here till there? Some of it is visible, some of it is not visible possibly, because you just touched that the model will automatically select and we don't need to do it. I would like to just uncover this particular, what happens within the model.
So now here the model chosen will be the motor, DC motor with flange coupling model, right? And these will be the different feature vectors to that particular model, which has already been trained There's a model that exists. Failure modes are known, patterns are known. We've got many data points, uh, millions of data points for that kind of model, which has trained on top of that. Now, and then there's an LLM which is trained based on that to give very pointed prescriptions, right? Which is human readable. Now, what happens is every time something like this is running in a real-time basis, that model is actually being run on a real-time basis on top of this data, and is actually tracking whether any of its trained failure mode methodologies and patterns are actually being seen in this particular piece of asset or equipment. And when it is seen, it converts it into what is called a syndication priority. You can see this here. It's called priority here, right? So it will show up here if it actually says that this equipment has matched a fault pattern in the past, looks like it's critical, need to send a diagnostic. Then it checks with what parameter failure mode it matches. So let's say the failure mode is unbalance. It'll match it with unbalance, give a recommendation based on the severity of the unbalance, so that action can be taken by the team. That is then converted through the LLM model into human readable language with explainability as to why it decided what it decided, right? So it's an explainable AI, which you saw. I showed you the diagnostics, I showed you the observations, I showed you the recommendations, right? That's all coming as an output of this. All these models are obviously running on top of this and behind this in some sense. I can't show you a model running. It doesn't work that way. But yeah, it's a service which is running continuously on top of this live data.
Okay.
There are two types of output that we deliver. One is a syndication, which means the fault pattern has been mapped and identified. The other is something anomalous, which may not be seen before, but it's definitely not what has been seen before. So it's something which is anomalous. It's not normal for that particular asset for running, right? And that comes out into your anomaly alerts, right?
Okay.
Right. So that is in these anomaly alerts. So for example, you can see all these equipment which have these particular anomaly alerts. And if you go to that particular anomaly alert, you'll probably see why that anomaly alert has come up, right? Which will give you an understanding as to why the model kind of said, hey, this is not matching any fault, but this is not normal. Something's off. And you can see that. There you go, right? Look at this pattern here. This is not normal. So now you know probably why that has come up. And now you know why it's not normal, because it also has a bearing fault in it. You can see the impacts over here. So you can see clearly there's a bearing fault, and it's not running in a good condition, right? So it's thrown out an anomaly alert. You can clearly see the impacts in the bearing. You can listen to it. You can hear the impacts. So yeah. So obviously it's getting worse and worse, and the fault is progressing. So that's thrown out in an anomalous condition, right? Which shows up in your anomaly alerts. And then you have process alerts if it's process induced. So then you have a lot of failure modes which are induced by the process itself, which has nothing to do specifically with the equipment, but the equipment fails at the end of the day. So you have the process data from the process of the plant, which actually tells you what process change is resulting in the degradation or the failure of an equipment, so that you can take action on the process side rather than on the equipment side itself.
So, if I may summarize it, so that means we actually have the view of faults from both mechanical, electrical, as well as the process-induced faults.
Yeah.
Okay.
So you can see this. Star Cement, Lakshmi Organics.
Okay. Interesting. Okay. Going back a little bit on the anomaly alerts, would the user be still validating that as well, if they agree or not, or how does it, what's the next step after the anomaly alert? Let's say, because once it is syndicated, that part is more clear because it generates a prescription report, clearly prescribed actions. That part is seen. So what happens on the anomaly? I'm just following it up to its logical conclusion.
Yeah, so every anomaly alert is converted into a diagnostic report or not, right? So for example, this Borosil, right? This example, right? You can see this is an anomaly alert here. It has been validated. It is true. A report has been already generated and it has gone to the user. We can take a look at that, right? So you can actually see what exactly happened. Why did that get, and then it's been validated. So our COE team validates every single anomaly alert. Make sure that if there's anything anomalous, which the model hasn't seen before, we tag it, send the notification to the user, and that tagging goes into the learning model for that particular asset, right? So now next time something like that comes up, it'll know what fault it was because it's been tagged, it's been sent, it's been validated by the field team as well, right? Hmm. And that's basically how how learning also works and how this works. So maybe if you look at this, you can actually see why the anomaly alerts have come up, and you can see the report has already been created for this piece of equipment.
Okay, so that means once the user validates it, it again follows the similar path of getting a prescription report, and then automatically the user takes the action, and then there can be possibly a true positive or a false positive, depending on the
Exactly.
type of impact. Okay, clear.
Yeah,
That's
exactly. And this is the fault that has been diagnosed. You can see it right here, right? So you can see that there's a coupling defect in this particular piece of equipment. And that's what caused this problem to spike up.
Now, if I request you to zoom back a little bit and then say which of these features or functionality is something that you think Infinite Uptime and PlantOS really does it better than whatever is available in the market over there. I know it's subjective. I know this is based on what you have seen, but be that as it may, for the understanding of the users watching this note now, so how do
Yeah.
you look at it purely from a science and technology perspective?
Look, I think, see, we have the system has the most amount of user validation in the world, right?
Mm.
So automatically, the way AI works is the more data, the more feedback, the more learning, better it gets. So automatically that makes this the most mature intelligence model for equipment globally for these industry segments, right? So the models are
Uh,
very, very sophisticated.
mhm.
The false negatives are less than 0.03%, which is absolutely world class, which means there's practically 99.97% uptime guarantee. It cannot be 100%. There's always going to be the corner case where we keep learning and keep improving.
Mhm.
So that's expected. But I think it's the journey and the direction that we've taken, that our customers have taken with us, that has resulted in this kind of a benefit for the industry, right? And every customer that joins the platform kind of benefits from it and contributes to it at the same time. So I think it's the sophistication of the models that makes it really world class. At the end of the day, jargon is jargon. How accurately are you predicting? How much in advance are you predicting? That's all that matters, right? Everything else is fine, right?
Mhm.
And can you do
Mhm.
it on all my types of equipment? Harsh equipment, complex assets, gearboxes, slow speed, high temperature, low temperature, um, complex equipment, internal bearings, right? All types of equipment, complex equipment.
Covering static also, maybe that is the
Yeah,
pointer that we
yeah,
haven't
yeah.
covered yet, the static part of the part,
Yeah, yeah.
the
So all of
process
this,
also.
exactly. We do thermography and oil analysis, and everything's part of the platform, right? So when it comes to equipment reliability, we talk about everything. We talk about online, we talk about offline, which is manual. We talk about thermography, oil analysis, NDT,
Mhm.
MCSA, all the critical tools that are required, which cover other failure modes that online vibration monitoring and acoustic monitoring may not cover. So
Mhm.
I think that is in a nutshell, the bottom line. And of course, we can talk about the uniqueness in the sensing technology, which is definitely there. Piezo technology is completely something that Infinite Uptime kind of brings to the table. You have the combination of piezo and MEMS at the right solution at the right application, which is also something that really benefits customers globally. Then we have since Infinite Uptime builds its own piezo, the sensitivity, the resolution, the logic, the crystal design, everything is designed for the kind of applications we're talking about. So if it's a slow speed application, if it's a high speed application, how do we make sure that it's most aptly designed for those applications rather than generic out of the box. So that's something that Infinite Uptime does really well, and that improves the quality of data. Once you have better quality of data, automatically your algorithms and diagnostics are better. So better
Mhm.
quality of data, highest frequency of data, highest validation from users. Automatically, that means the models, pretty much best in class in the world.
And
And that's
for
yeah.
those who must be wondering what is automatic and most validation by users, here's the stat. Out of the 28,117 prescriptions generated so far in Q2, of 2025, which is ending June, 99% of them were actually acted upon, and users have validated whether it is true positive or false positive. That means 99% of those 28,117 prescriptions have been acted upon. As you can see on the
Correct.
screen, that translates to 26899 live. Up. The number of total notifications just increased between the last week and now it's 29471. Okay. But the
Yeah, and
date point that I
26900
was,
is actually acted upon.
yeah, so that is still again looking at it purely, that's a very fairly high rate. And you can see this is the lifetime, but precisely only for the last quarter, within which it's actually 99% of those insights that are generated between 1st April to June 30th, 2025, they have been taken care
Correct.
within a mutually agreed SLA time, and the users have given the validation and feedback, including
Yes.
both true positives as well as false positives.
Correct.
Okay, so that is very well put. And Ronak, now I want to just zoom out a little bit on our own advanced sensing technology. And since we are looking at the prescriptive AI part of the capabilities, how open and how easy or difficult it is for PlantOS to ingest data from other systems. Because integration is the name of the game now. No AI platform worth its salt can actually claim that only my data will come from my own sensors. I'm not going to talk to anyone. So please help us layer this out a little bit on integration and how easy it is for a existing plant head or a digitalization head to actually look at it and put it in their heterogeneous jungle of a plant currently.
Now, so PlantOS can be integrated with any sensing technology that they might already have. For example, if they already have purchased piezoelectric sensors from various other companies in the past through capex mode, maybe some sensorization project done in the past, some plants doing it from their plant budgets in pockets, right? I mean, all those can be brought to PlantOS. That's not a challenge. There are two types of sensing in that. There's milliamp, millivolt based. Millivolt based is where you can get diagnostics and prognostics and prescriptions. Milliamp based is really for tripping purposes. So that's not something that is ideal to be integrated into PlantOS. Any other system, MEM sensors, which we have integrated quite a few, it's a pure play API integration, right? And those are fairly straightforward. And we've done many of those in the past. For example, you want to use something in a SO environment, ATEX environment, C1T2, right? You can't expect one company to have sensors that works everywhere and it's world class and it does end to end and everything, right? So that's where the integration capability is very important. PlantOS integrates into the right sensing technology at the right application for the right environment, right? For the right locations. So that way you get a holistic view across. So, let's say you're a manufacturer, you have plants in the US, you have plants in Europe, you have plants in Middle East, you have plants in Asia, and you have different, types of sensing technology that you need to use. And each of them have different certifications in different regions, right? How do you bring all of that together? And that's something that PlantOS can support with. We have our own sensing technology that we make and manufacture ourselves. We also partner with the right partners who manufacture and make world-class sensing technology. It's a very niche for those specific applications. And together we are able to kind of cover the entire, like you said, jungle of heterogeneous types of equipment and sensors globally.
And if I ask you to cover a little bit on the process side on the supervisory layer, because that also is a very interesting angle, what all can PlantOS ingest, and also on the output side, where all can this output be integrated into? These decisions, these AI assisted decisions can be integrated into.
See, the prescriptions and the recommendations can be integrated into any PMMS system, any SAP, ERP kind of system, or any other workflow that might be used by any plant. Basically, this is intelligence, right? And this is very niche, mature, sophisticated intelligence for a specific use case for specific industries. And it's kind of what you call, typically if you want to put it in the best of breed kind of decision making, when you get the best intelligence for what it's trained on, and you get all of them together, so you kind of get the best solution for a plant. You have to get all of them to talk to each other. So we have a complete API interoperability and integratability capability within the system. You can talk to any other system. Completely deep integration is possible. Two-way integration is possible. So, so I think putting this as part of some existing ecosystem is something that PlantOS really works.
Okay, now again zooming out in terms of what is PlantOS integration capabilities, and then looking at it from the customer's point of view, what else is available outside there, how easy or how difficult it is to integrate. Good that we can integrate everything and integrate into everything. That is also good, but how fast? If you have any comparative of what is happening in the market today in terms of integration, what could be the timelines and what is possible with PlantOS?
I would say 1 month is a realistic deep integration timeframe. But it could be a little
across
more
the
depending.
plant.
Yeah, but it depends on the complexity in the plant itself, right? So sometimes plants are configured with very complex implementations of ERP or CMMS. So if it's plain vanilla, the way it usually is, right? Most of them, then it's a month or so. But if it's complex, then it could be more than a month. So I would say that's more or less the time frame for the integration to take place.
It's very interesting. So we are not talking in terms of quarters. We're actually talking in terms of weeks. Because month and at
Weeks
the
to
end of the
months,
day itself is
yes.
just 3. Yeah, that's good. Thank you so much. And the last part, which is in terms of the ROI, after doing all this, what would be the time frame that you have seen?
See, I've seen ROIs from weeks to months. Weeks is, when you predict and prevent a major breakdown on a super critical equipment, single line, high lead time of spares, high MTTR, you know, that's it. That one saving is the ROI for the entire program for probably 2 years or 3 years. It could be months because that's the probability of that happening in the first few weeks is fairly low. But in the first few months, you definitely save enough number of incidents from happening, and you streamline operations well enough to kind of pay for the entire program. So we've seen weeks to months. It's never more than 3 to 4 months. That's the max.
Okay. The last one is my favorite question, which is because I keep getting asked this: is Infinite Uptime and PlantOS a downtime only company? Do we do anything else other than downtime?
Yeah, so Infinite Uptime is started as a reliability company, right? So everything to do with reliability is, so we started with rotating, which moved to static, critical, non-critical, supercritical, covering now the entire gamut of reliability end to end, right? All through a single prescriptive engine, which can then integrate into the workflows of the plants. Recently, we've also acquired capabilities to integrate into process information and correlate and contextualize that with our reliability solution. And we are currently maturing in our journey towards improving reliability, including process induced faults, because now you have contextualization, so you have a larger or a wider range of failure modes that we can work on and actually start impacting MTBF directly. And the other is actually looking at the process energy efficiency itself, right? And starting to improve on the energy efficiency, because the moment equipment start degrading, they start taking more energy. And that's measurable, quantifiable. And now you can start generating better prescriptions and recommendations in terms of when to take that action, right? More precisely based on not just what's the potential impact, but also how much are you losing for every hour that you're running it in the condition that you're running it in. So I think that balanced recommendation is something that is also of interest to our customers, as well as what we are working on. So I think these are the two areas: energy efficiency and really impacting MTBF as a whole, rather than just saying mechanical or electrical, just one part of the story, right? I think that's kind of the direction that Infinite Uptime is taking towards eventually building towards a complete APM.
Okay. So asset performance management, but today to concretely start with, eliminate the downtime hours and reduce the cost of maintenance and cost of energy,
Yeah.
and increase utilization rate and productivity, and AI assisted workflows.
Yep. Absolutely.
That is where that encompasses our journey towards taking our customers towards possibly
But
a
I think,
semi-autonomous plant.
but I would still say the most impactful part of infinite uptime is the adoption, right? I think we have the best adoption in terms of 99%. It is user validation for every prescription that's going on there. That speaks for itself, right? So that's the adoption that we've been able to drive through our system, and that's because we are able to build trust in the system, right? That people are
And
using it.
adoption is good, but could you also spell out what kind of retention do we have?
So yeah, we currently have less than 2% churn, right, annual, and we have 150% plus net revenue retention, which means customers love the way we work with them, and they deploy more and more because they're seeing value for every dollar that they're spending with us. So they're just multiplying value, and they're multiplying savings and benefits rather than adding costs. And I think the moment we get into that zone of the savings being disproportionate to what they're spending, uh, the NRRs start growing. So we're seeing those NRRs significantly above 150% regularly, quarter on quarter for the last 10 quarters, right? Which means customers are seeing significant ROI. Otherwise, they wouldn't grow their investment with Infinite.
So, as a summary for this session, why is PlantOS the world's most user validated prescriptive AI platform? Here's what it is. 99% user validation from the customers that are adopted, and by the way, less than 2% of them are leaving. That means 98% customer retention, and the net retention rate, net revenue rate, NRR, is you said more than 150%. So that means each customer is growing because we are showing value quarter on quarter, week on week. So the show and grow model is working, and that's what all of this is being done at a phenomenal or a decent benchmark of 99.97% accurate insights and prescriptions being delivered. So all these put together, this is what encompasses why PlantOS is the world's most user validated prescriptive AI platform.
Yep.
Okay. Thank you so much, Ronak. Really appreciate it.
Yeah. Thank you. Thanks, Kalyan. Take care.
Thanks.